So we have this cone of liquid and it's evaporating, and we know the depth is changing at this rate, -0.3 centimeters per hour. The first question here, first prompt here, A, is find the volume V of water in the container when H is 5 centimeters. Indicate units of measure. Okay, so when the height is 5, the radius, well, okay, so this cone, it's a right circular cone, so the ratio of the diameter to the height is always going to be 1 to 1. So that means if the height, if the height to the diameter is always equal to 10 to 10, or the ratio is always equal to 1, then the height to twice the radius is equal to 1. Or, it's the same thing as saying the height is going to be twice whatever the radius is. So this is always going to be true. And let me write it as we're going to get everything in terms of h. So that means the radius is equal to the height over 2. So we're going to take this and we're going to rewrite our volume formula just in terms of h. This is 1/3 pi r. Here's our r, and we want to do r squared. So that is going to be h squared over 4 times h. So this is 1/3 pi. Let's make sure we have this right. This is pi over 12 times h cubed. So at h equals 5, we would just put h, I'm sorry, it says when the height is equal to 5 centimeters, we would put our centimeters in here, and this is why why units are important. Pi over 12 times 5 centimeters cubed. Our answer, and this makes sense for volume, is going to be in cubic centimeters. So whatever 5 cubed is 125. We have our pi, and that's divided by 12. So there's our answer for A. There's our answer for A. Let's look at B. Find the rate of change of volume with respect to time when h is equal to 5 centimeters. Okay, then again, if we're going to look at our volume equation right here. Our volume equation right here. Or let's use this one right here. V is equal to pi over 12 h cubed. Okay, and we're going to take the derivative of that with respect to time. The differential operator, that's right, preserves equality. So we need to take the derivative of both sides. So the left side is dv dt is equal to, well, pi over 12 is just a constant, so we use the constant rule. And then we have 3h squared dh dt. That's just following the chain rule. And we want to know when h is equal to 5, so dv dt is equal to pi over 12 times 3 times 5 squared. And we're told what dh dt is, right? It's -3/10. -3/10. And indicate units of measure. Okay, well, here just for units, let's step back a little bit here. This is, let's go all the way back to here. What are our units? We have 5 centimeters, right? That's our height. It's measured in centimeters. We're squaring that times dh dt. Well, our dh dt is -3/10 centimeters per hour. Well, this is kind of a dimensional analysis. We have centimeters cubed times centimeters, so our answer is going to be in centimeters cubed per what? Unit of time, per hour. That makes sense. Our volume should change our rate of change should be some volume measure per time. So let's multiply this out. Don't forget PEMDAS. We're squaring this. This is going to be pi over 12 times 3 times 20. Oh my gosh, All right, so, and it's there's going to be a negative here, right? Don't forget this negative sign right here. I'm just going to leave it this way. Negative pi times 3 times 3, about 3 squared times 5 squared divided by 10. And let's do the, okay, so that's the, whatever number that is, that's the answer for B. And I don't think I missed anything. 3 squared, 5 squared, 12 times 10, and the pi, and the negative. Okay, so that's your answer right there. Let me make that. So that is your answer for B, and I will do part C in just a second.